Yeah.
Good morning, students. So once you have to see what is the syllabus you have to cover so far, that is the data warehousing and data mining. So in the first unit, you have all the concepts you have to cover. What is the data mining and what are the kinds of the data it can be mined, patterns, technologies, kinds of applications, and attribute types, basic statistical description of data, visualization, measuring data similarity and dissimilarity. So this is the first unit you have to complete it, as well as second unit also you have to complete it, data pre-processing. So mainly we have to use the four types of tasks you have to perform in data pre-processing. Before the data warehouse you have to implement it. You must be perform these tasks. That is the data cleaning, data integration, reduction, and transformation and discretization. So these are all concepts you have to cover, and as well as you have to cover classification basic concepts, general approach of solving a classification problem, decision tree injection, working of decision tree, building of decision tree, methods expressing the attribute test conditions. These are all concepts you have to complete it, as well as blessed split algorithm, decision tree tree injection. So how to measuring the decision tree injection, you have to represent it with that. These are the concepts you have to complete it in classification basic concepts as well as advanced concepts. You have to cover all this so far. And the next one is the alternative techniques of classification. Bayes theorem is also completed. Naive Bayesian classification, Bayesian relief networks. So only 3 concepts you have to cover. Already these are the concepts you have to cover. So once you have to revise this one, then you have to start the 5th unit. Already frequent item center algorithms you have to discuss. Once you have to, again you have to revise the 4th unit. 4th unit, and then in the 5th unit you have to complete. Here you have to see classification, the basic classification methods. And in the basic classification methods, mainly you have to discuss what are the basic techniques you have to use to build the decision trees and the Bayesian classifiers. How we can divide these classification methods, Bayesian classification as well as rule-based classification. So these are the concepts you have to discuss in the third unit, and the fourth unit we have to discuss is that is the Bayes theorem and Bayesian classification networks. Navi Bayesian classification and Bayesian belief networks. So concepts you have to cover: decision prediction, attribute selection measures, information carrier. Index, triple name. So see here, this is the first one, Bayesian classifiers. Bayesian classifiers are simply call it as statistical classifiers, which is you have to represent it with the Bayes theorem. Bayes theorem is simply to give the name by the Thomas Bayes. Is a non-conformist. Here's the probability mainly we have to find out with the Bayes theorem. That is a conditional probability. So generally, this Bayes theorem, you know that conditional probability of H to X, you can represent it with this probability of H to X, conditional probability of X. So generally, you have to call the probability that hypothesis H holds, given the evidence or observe the data tuple X. So if the X is there, then H is the holds. Simply the probability belongs to class C. Have to represent it with the Bayes theorem. That is the conditional probability. Simply you can say that the conditional probability. The posterior probability of this one, H is conditional on X. For example, data tuples is confirmed to customers described by the attributes age and income respectively. If the X is the 5 years old customer, if his income is 40,000. Suppose H is hypothesis, our customer will buy a computer. So if the is the 35 years old customer as well as his salary is $40,000, then only he can buy the computer. Otherwise, he could not buy the computer. So based on that condition, you have to represent. Some of the people they have to buy the computer, but most of the people they have to buy. See here, the posterior probability of H conditional on X. Simply posterior probability and prior probability. In contrast, probability of H is the prior probability. The prior probability of H, example, any customer will buy the computer regardless of age and income, any other information for that matter, that is the prior probability. Posterior probability, probability of H to H conditional with the X is based on more information, that is the customer information. superior probability, that is the probability of H, that is the independent of X. So here, two things one you have to understand in the Bayes theorem. First one is the based on other factors. Based on other factors, the probability will be represented. With the independent of representation, that is the another way, that is the superior probability. And based on with the other condition, that is you have to represent it as posterior probability. So for example, here where the X particular person is the 30 years old and his income is $40,000, that is the sum X. So if the if the customer is buy the computer, hypothesis we can represent it. He can buy the computer, that is the based on that X condition, that is the posterior probability. If not belongs to age and income, they want to buy the computer, that is the independent, that is the PA probability. So here you can represent it. The posterior probability of X condition on H, that is the probability that a customer, if the X is the 30 years old and earns 40,000, gives that we know that customer will buy the computer. If the probability of X, the period probability of X, using our example, that is the probability that is the person whose set of customers is 38 years old and earns 40,000. So based on that, these all things, you can buy the computer, you can represent the Bayes theorem. Bayes theorem is useful to provide the calculating the posterior probability, that is the probability of hypothesis of with X from probability of H and probability of X to H and probability of X. So this is simply you can represent it the posterior probability. The probability of hypothesis to X, that is equal to probability of that is the X to hypothesis into probability of hypothesis divided by probability of X. That is simply called it as Bayes theorem. So this is the regarding to the Bayes theorem. This is a very important representation of Bayes theorem. Probability of H, that is hypothesis to X, equal to probability of X to hypothesis, the probability of H, and divided by probability of X. This is simply call it as Bayes theorem. So explain about an external point of view, they will ask this type of question. Explain about the Bayes theorem. So that time you have to explain with that Bayes theorem with the definition. Bayes theorem is simply call it as Bayes terms. In terms you have to say that is the evidence of the particular hypothesis, that is simply call it as Bayes theorem. So if the H is the hypothesis, that is the evidence is represented as X. That is the probability of H to a hypothesis to evidence X. Clear? That is the regarding to this Bayes theorem. That we have to. This is the Bayes theorem. You have to represent it. So based on that, you have to represent the Bayes theorem. Can calculate the posterior probability and period probability. Period probability means directly a particular evidence. Directly you can find out the probability, or hypothesis you can find out the probability. That is the P of H or P of X. These all are independent. So for that hypothesis and a particular X, evidence X, both you have to find out the probability, that is the period probability. You want to find out the posterior probability, that is the probability of hypothesis to the evidence of X is equal to probability of X with the evidence X to hypothesis into individual probability of hypothesis divided by probability of evidence X. This is the Bayes theorem. Yeah. Then Navy Bayesian classification. This is the classification type. You have to represent the Navy Bayesian classifier, or simply call it as classifications are divided into two types: Navy Bayesian classification and rule based classification. In the Navy Bayesian classification, or simply call it as simple Bayesian classifier, how it works as follows. Generally, you have to working like this. Let D is the training set of the tuples and then associated data labels. As usual, each tuple is represented by the n-dimensional attribute vector x equal to x1, x2, and up to xn. Simply, you can represent the n measurements made on the tuple from the n attributes, respectively a1 to an. So here, that is the n-dimensional attribute vector we have to consider here. That is the n evidences. That is the x equal to x1, x2, x2 up to xn. These all we have to represent as evidences of a particular thing. D is the total training set of the tuples of these class labels. And what are the attributes here? N attributes we have to use. That is a1 to an. Suppose there are m classes C1 to Cm. Given a tuple of x, the classifier will predict that x belongs to class have x belongs to the class having the highest posterior probability condition on x, that is the Navy Bayesian classifier, predicts that tuple x belongs to the class C of I if and only if that is the P of C of I with the condition of x, that is the x means that is the evidence is always greater than P of probability of C of j with the evidence of x. For all one is less than equal to j and less than equal to m. So j is not equal to I. This is the based on that condition you have to represent the Navy Bayesian classification. We maximize the C of I with the condition of x or evidence of x, the class C of I, which probability of C of I condition on x is maximized. It's called maximum posterior hypothesis by the Bayes theorem. మనం యాక్చువల్గా లాస్ట్ Bayes theorem డిస్కస్ చేసాం కదా. That is the P of H hypothesis of with evidence x equal to P of evidence of x with the hypothesis into probability of H as well as the probability of evidence divided by probability of evidence, that is the P of x. So based on that, here you can apply the P of probability of C of I x is equal to probability of x x with the probability of x condition with the C of I and probability of C of I divided by probability of evidence. That is the Navy classification, Bayesian classification. So probability of x is a constant for the all classes only. That is the P of x condition with the C of I, as well as probability of C of I needs to be maximized. So you can represent this up to probability of with the C1 to Cm, and otherwise is to maximize the probability of x with the condition of C of I. So that is the class period probabilities we have to represent it. C of probability of C of I equal to C of I comma D by divided by D. C of ID is the number of training tuples of a class C of I in D. D is the training set. D is the training set. In that training set, we have to consider the only C of I. That is the independent probabilities you have to find. And next one is the fourth point, that is the class conditional independence. Given data sets with many attributes, it would be extremely continuously or simply computation continuously we can expand, continuously we have to compute probability of with the evidence X condition with the C of I. To reduce the computation in evaluating the probability of evidence X with the condition C of I, the naive assumption class conditional independence is made. So simply you can represent the relationship between the attributes. Probability of X condition with the C of I equal to for phi of that is k equal to 1 to n, that is the p of xk of with the condition of C of. So that is the p of x1 to up to xn. You have to find out the probabilities. All you have to multiply it. Pi represents the multiplication, whereas sigma represents the summation. So here we can with the product of all these probabilities. So if the AK is the if AK is categorizable, then P of xk, C of I is the number of tuples of the class, C of I is in D, having the value of x of k. For AK divided by the C of ID, the number of tuples of the class C of I in D. If AK is the continuous value, if you need to do a bit more work, but the calculation is pretty straightforward. A continuous valued attribute is typically assumed to have a Gaussian distribution with the mean of mu and standard deviation with the rho defined by this. C of x mu rho is 1 by root of 2 pi rho e power minus x minus mu whole square by 2 rho square. So by this formula, you can find out this continuous value at Gaussian distribution method. This is the simply you can represent it, and how it works is along with the example. Let example if the x equal to, that is evidence with the x 35 years old and 40,000 salary, where A1, A2 are the attributes of age and income respectively. If the class label attribute is by the computer, the associated class label X is by the computer, yes or no. Suppose age is not being discretized and therefore exists the continuous valued attributes. Suppose that for the training set, we find the customers in D who buy the computer 38 plus plus or minus 12 years of age. In other words, the attribute is in this class we have 38 years and with the row of 12, and that is the 30 years old, 35 years old, or less than 35 years, plus or minus 12 years, we have to consider here. We can flag these quantities along with the x equal x of n equal 35 for our tuple x in the equation 1 to 3. So here the equation 1 3 we have to represent it here. This is the C of that is the Gaussian distribution of x nu of rho 1 by 2 root of 2 pi rho e power minus x minus mu whole square by 2 rho square. So by using the Gaussian distribution method, you can process here to estimate the P of A is equal to 35. Why is the computer S? So the quick review of the mean and standard deviations of the calculation, you can find the value. To predict the class label of x, P of x, condition with the C of I, and the individual probability of P of C of I is evaluated for the each class C of I. The classifier predicts that class label of the tuple x is the class C of I if the and only if, that is the conditional probability of that is the probability of x condition with the C of I and a probability of individual, that is independent of probability of C of I, is always greater than P of X condition with the C of J and P of C of J, that is independent. So the J value must be in between the 1 and M. So the J value is not equal to I. So that is simply you can say that Bayesian classification Bayesian classification you have to complete it. See this example, it shows how Navy Bayesian classification works. So if the X is S, youth, and income is medium, student is S, credit rating is fair. So this is the values, you know that. If you want to buy the computer or no, that you have to represent it here. We need to maximize the values, that is the I value 1, 2, 3, pre probability in each class can be computed based on training tuples to get the value who are the greater than 30, 35 size and as well as 40,000 salary. So most of the people they have to buy, that is the 0.6%. But buys the computer, you have the 0.3%. If the age is youth and buys the computer, is the 2% you have to purchase. And if the age is youth and buys the computer, no, that is the 6% they don't want to buy. So income is medium. So how many people they have to buy? So that is the 0.4. As well as the medium income is medium and buys the computer, no, that is the 0.4. And if the student is S, buys the computer S, that is the 0.667. Those people they have to buy. So this is the way you have to getting the probabilities. So all these probability as you have to multiply it. Is buys the computer or no? You can get the by Bayesian classification. Here you have to apply this one. So in this formula, you can apply these all values. You can get here. See here, this is the way you have to find out the values. So that is the 0.004. These are the people they have to buy. If the buy is the not buy the computers, that is the 0.6 buys the computer, no, who is the multiplier of these values, you can get the 0.019. Whereas buys the computer, they have to 0.044. This is the way you have to find out the you want to buy the computer or not. That is you have to find out with this Bayesian classification. This is the Bayesian classification main classification method. He want to buy the computer or not buy the computer based on given information. Easily you can understand by the who are selling the computers. Those people easily can identify based on that given information. That is the probability. You want to buy the computer or no? So just for asking the questions, based on that condition, they give the answer. You can identify he want to buy the computer or no. So that is you have to analyze. That is the basic classification methods as well as advanced classification methods. So this is regarding to this Bayesian classification, and similar way you can use the rule-based classification also. So in the rule-based classification, you have to use the if-then rule of classification. If-then rules mainly you have to represent it here. What are the rules you have to use? Decision trees, training sets, sequential covering algorithms. So these all you have to discuss with the rule-based classifications. So using the if-then rules classification, rules are good way representing the estimation. That is simply you can represent information you have to represent it with the bits of knowledge. A rule-based classifier uses a set of if-then-else rules for a classification. If-then-else rule is the expression in the form of if condition is true, then it's conclusion. If the age is youth and the student is S, then buys the computer S. That is the way you have to say it. And he has the ability to buy the computer. This is simply can represented as a rule-based classification. If the age is root is and the student is S, you have to buy the computer S. So what is the coverage and accuracy of given rules? Coverage and R of n covers by divided by of data tuples. And a similar way accuracy you can find out n correct what is the way and what are the covers. So example you have to see here. Coverage is 2 by 14, that is 14%, and accuracy is 100%. Rule accuracy and coverage, you have to find out what is the credit rating. So based on that, here you have to rule orderings, you have to present. This is a rule extraction from the decision tree. If then also rules, you have to, if the age is youth and student is no, then he buys the computer no. If the age is youth and the student is yes, they buy the computer yes. If the age is middle-aged, then you have to buy the computer S. If the age is senior, credit rating is excellent, you want to buy the computer. If the age is senior and credit rating is fair, you don't want to buy the computer. So based on these values and extracted from this figure, you can get that easily. You can you want to buy the computer or no? Easily you can add it with the decision tree. Rule induction using sequential covering algorithms, we have to use it here. So this is regarding to that Bayesian classification. And the last one is the Bayesian relief networks. We'll continue in next class. So fourth is completed. Then we start the ones you have to revise. Then. So we have the remaining 2 units. Thank you.